Hello guys, this is Prime Concept. We want to solve a problem under arrangement of capacitors and then to find charge, right? Now we have a problem here on the body. Question says, for a combination of capacitors shown below, that is to say in this figure, calculate the equivalent capacitance of the combination and then the charge on the 15 microfarad capacitor. So we want to find the charge here. So the first thing we want to do is to be able to find the equivalent capacitance of this system. That is the first part of the question. And then the second part of the question says find the charge in this. And before I solve this problem, if you have been following my videos and they are giving you values, please do well to subscribe to my channel so that you would always get notification in sequence, right? And then like whenever you watch so that it can reach a wider audience. Share with your friends so that they can also benefit from my videos. Thank you. And let's solve this problem. So first, you would consider and understand that these two capacitors are arranged in what form? You are correct. They are arranged in parallel. Now, since they are arranged in parallel, I will start from them. I will call it my C equivalent 1, my first equivalent. Now remember, when capacitors are arranged in parallel, the equivalent is going to be their direct addition. So it's going to be 10 plus 20, 10 plus 20, which would simply give me what now? 30 microfarad. Don't forget, it is in microfarad, right? Now, so it means this has been merged to 1. Now, I think I would rub this part since you have the question already so that we can retain our circuit. Now, if I do this, I'm going to redraw this circuit, and this circuit would be something like this. This is our 25 microfarad. Then this is my 15. Then this two has become 1, which I'll do like this, right? So this is what I have, these two becoming 30. Then connected to my potential difference. Now, if you watch, these two are now in what form? You are correct. Both of them are arranged in series. So if you want to get the equivalent, I think I'll be using the short approach. I told you when you have only two capacitors in series and you want to find the equivalent, what do? Their product over their sum. So it means I will call my C equivalent 2. My second equivalent is going to be the product, that is 15 times 30 divided by their sum, 15 plus 30. So if I do this, I would have 15 times 30 to give me 450 divided by 45, right? So which is going to simply give me 10 microfarad. So now I've gotten this, so I can redraw this circuit very quickly. These two capacitors has now become 1. So this is what I'll then have. I'll then have just a single capacitance here, which has a value of what now? 10 microfarad. Now you would notice again that this and this are now arranged in what form? You are very correct. So both of them are arranged in what? In parallel. Now since they are arranged in parallel, the equivalent, C equivalent for parallel arrangement is what? Their direct sum. So our equivalent is simply going to be what now? 25 plus 10, which is going to give us what now? 35 microfarad. And this is the equivalent capacitance of this whole system which we have gotten. Now, this is the first part of the question. The second part of the question said we should get the charge flowing through the 15 microfarad capacitor, the charge that would flow through this. So if we want to do that, what it simply means is that we are going to resolve these two capacitors. We're going to resolve them as 1, right? And then we can now calculate the charge that is flowing through, because the total charge coming from here, when it gets to this point, what will happen? It will split. Part of it will come here, and then part of it will come through this place, right? So the charge that flows through this place is what we want to actually get. So the equivalent capacitance we've gotten in this particular lane is this combining with this, which we called, I think that is what we have as 10, the equivalent capacitance in this place. We have it as already as 10 microfarad. So the charge that will flow through here is what we want to get. The charge that would flow through this combination is actually the same charge that would flow through our 15 microfarad capacitor. So if we can get the charge through the combination of this and this, that same charge is flowing through this, right? And let's quickly get that. So we have this is our 60 volts. So if you recall, we said for parallel arrangement, the potential difference or the voltage is the same. So what is the voltage across this 10 microfarad? You are very correct. The voltage is what? 60. Now what is the formula you would recall for capacitance? You will recall that Q is equal to CV. Now since we are considering this capacitance, it means that the value is 10 microfarad. So I would have that my Q is 10 times 10 to the power minus 6. Why minus 6? Because it is micro, so you have to convert that times the potential difference. The potential difference here is still 60. So I'll say by 60. So 60 times 10 is 600. So I have 600 times 10 to the power minus 6 coulomb. Or you can simply say 1, 2. So you would have 6 times 10 to the power minus 4 coulomb. So this is the charge, right? That is going to flow through our 15 microcoulomb capacitor. And I believe this concept is very clear to you. If you have watched this video up till the end, please do well to hit the subscribe button, like my videos, and comment and share with your friends so that they can also benefit. Remember, this is Prime Concept. Thank you.